Hello and welcome back to Cracking the Cryptic, and a very happy birthday to my daughter. And because of that, I have chosen a puzzle called 18 Radars by Utopia. It came in a little while ago, but we're going to have a go at it today. And yeah, I'm looking forward to that. It's got a very interesting rule set, a bit miracle-ish, which reminds me that on Patreon we have our quite approachable Sudoku hunt, where 7 puzzles, each themed around one of the apps that we have out, including Miracle Sudoku. There is therefore a non-consecutive sort of puzzle in it, but they are all quite approachable. None of them are quite as easy, I think, as a genuinely approachable Sudoku puzzle, but all of them are a lot easier than the puzzles we've been including in Sudoku hunts in the past 2 or 3 months. So loads of answers in already. Very many congratulations to everybody who did it within the first 24 hours or about 36 hours by now. Very impressive. Hundreds, basically, of answers coming in. Well done. So that is for Patreons. That's on our Patreon page, along with, I'm not sure if it's up yet, actually. Simon is putting up his Fistamafel riposte to me, which... well, have a look at it if you get the chance. I think it's quite amusing, frankly. So do check that out. Also, of course, there's our apps, there's our merchandise, all on the links under the video, along with Sven's SUDOKU PAD. But the first link, as long as I've got it right today, I managed to leave off the link for half an hour yesterday, apologies for that, is to this puzzle by Utopia, whose debut I think it is on the channel. And it's called 18 Radars. Normal Sudoku rules apply. No 2 adjacent cells can have consecutive values, so that can't be a 5 and a 6. 2 cells separated by a knight's move can't have the same value, so that constraint applies throughout the puzzle. Radars are cells that have a value indicating the distance to the closest 9 on their row or column. So, if the closest 9 to this cell was there, that would be a 4. Now, that would require there not to be a 9, as I understand it, in those cells. Obviously, in the rest of column 8, there wouldn't be another 9 by Sudoku rules. But I think that's what's going on. All radars are marked grey, so every time there is a cell which shows the distance to its closest 9, it's marked. And every marked cell is a radar. So there's a lot to remember in this puzzle. Not that there's a lot of rules, but they're all quite easy to forget. The non-consecutive constraint, given that we have no actual given digits to start with, which is a brilliant setup for the puzzle, by the way. The non-consecutive, the knight's move constraint, and this radar constraint, and the fact that there's a negative constraint on the radar, so that if that was a 1, we couldn't have a 9 there because it would have to be marked grey. I mean, yeah, there's a lot to forget as you go along, is what I'm trying to mean. So we'll see if I manage to remember these rules. But I am going to... I don't need to do this. It's not gas. But anyway, I am going to start the puzzle now. Have a go at it on the link if you feel like it. You can judge from the video length how hard I found it. But I'm going to start now. Let's get cracking. And that's really easy to say, but I haven't got a clue how you start this. I guess if we had 4 greys in a column, I mean, I think all the grey cells, the radars, are low digits, and the fact that they're kind of disposed somewhat diagonally and not seeing each other a lot suggests there's a lot of the same digit in the grey cells. But I mean, that's just theory. If we knew where some 9s were, that would be interesting. Oh. How about central cells of boxes? No, that's no good. I mean, there must be a 9 in the box, but if it's in one of those cells, This can be any number. If it's in one of those cells, this has to be a 1. Right. Right, it's the negative constraint on these mines, on the radars, and they're not mines. Yes, look at this cell. Okay, I'm going to say that this can't be a 9, and that's because both of these would be 1s, and they're in the same box, or both of those would be 1s, and they're in the same row. So let's start marking cells that can't be 9s. Anything that's seeing two cells the same distance away and those two cells see each other can't be a 9. So that one sees those two. This cell, for instance, can be a 9 because they could both be 1. They're in different boxes, rows and columns. But this one can't be because of those two. They'd both be 1. So these two, they see a pair of cells. These two, there's a sort of Battenberg thing going on. None of those can be 9s. That's not a 9. That's not a 9. It comes between those two. That one sits between two cells. That one. This one's all right to be a 9, I think. Okay, then in column 5, one of these two cells is a 9. And by a knight's move, they see quite a lot of different cells. Well, by knight's move and regular Sudoku. So that cell, for instance, will see one of those 9s, either by regular Sudoku or by knight's move. So it can't be a 9. The same is true for this one, and this one, and this one. So we can green all of them. They can't be 9s. Now 9 only has 2 possible places in box 2 and 2 in box 5. Oh, look, only 2 possible places in this column. So again, that's green, those two are green. I think that's all this time. But now there's only 2 possible places in box 8 as well. So either those 3 are a set of 9s or those 3. Now what would give a problem there? With those 3 you'd have 1, 1, 2 up here, 2 there. I don't know. I may have to keep looking for cells. Those 2 have to contain a 9. These 2 have to contain a 9, so that can't be a 9. Because it sees them both. Now, what am I forgetting about the constraints? This is a useful start, I think. We're getting somewhere. These patterns aren't very good. When these possible places are a knight's move apart, they don't see things by interesting knight's moves in other boxes. And the same's true there. These are a bit more interesting. They rule out that cell and that cell, but we've done that now. Oh, wow, this is another reason they're interesting here. I think they say that this is a 2. Since we know there isn't a 9 in any of these cells, this radar cell can't be a 1, but it must see one of those 2, so it is a 2. We've got a number in the grid. And what does that tell us? Right, that tells us what this is. It can't be a 2 now. If that was a 9 and that wasn't, this would be a 2. That would be the closest 9 it could see. That is not a 2, but it must see one that's either 1 or 2 away. So that's a 1 and that puts a 9 here. and that puts a 9 here, and that puts a 9 here, and now we are starting to get somewhere. That's not what I was trying to do. That's what I was trying to do, remove the 9s. Actually, also, I can colour those green because they can't be 9s anymore. Now, we've got a little more certainty over 9s. In fact, we can green everything in their rows. Let's start with that. There we go. And we can green knights moves away from these 9s. That doesn't give many cells. But can we go on? This can't be a 1 or a 2. So there is not a 9 here, because that would be a 2. So that's odd, but true. Oh, this is a 1, obviously. Yes. Well, sorry, we can fill in lots of numbers. This is a 2. This is a 2. That's the closest possible 9. This is a 2, because it's surrounded by green. It sees that one. Is this a 3? Yes. It can't see a closer 9 in any row or column. That is a 3. This could be a 3, but we don't know. This one sees 1 4 away, but it might see a closer one. This one also sees 1 4 away, but it might see a closer one. So, what else? Okay, let's not forget the non-consecutive rule. Oh, and the knights move rule. Look, I think I can place 3 in this box by the rules. 3 can't be there because of the non-consecutive rule. It can't be there by Sudoku, or normal Sudoku rules, and it can't be there by knights move. So there is a 3 here, and that is seeing a 9 in one of those 2 cells. That's so strange. Yeah, look, none of these can be 3 now. None of those can be 3. Mostly by the non-consecutive rule being next to a 2. So that's a 3. This is a 3 as well. And they keep popping up in the radar cells. So this one, that's 4 away. So again, it's seeing... No, it's got to be here, the 3. 3 away from that is that cell, that cell. It must see a 9 over this side. So that becomes a 9. Oh, and of course, the whole knights move thing, that sees all these 3 cells. So we get a 9 there, we get a 9 there. That's not a 9. One of those 2 is now. One of those 2, there's probably a way we know which one. Ah, this in the bottom row is definitely a 9. Right. Oh, and that's fixed. All the 9s. Bingo. So they're all done suddenly. I might as well be very thorough and green out the rest of the cells for completeness. I think that's it. So we've got all the 9s. Now we can obviously fill in all of the grey cells, because that's just by maths, by simple arithmetic. That's 2 is its nearest. That one's a 1. It's right next to 1. That one's a 1. That's a 2. And there we go. We've got all the coloured cells done suddenly, like minutes into this puzzle. And now, okay, we mustn't forget the knights move. We mustn't forget the non-consecutive rule, which I think is going to be the most helpful. And we mustn't forget the negative constraint on radars, just in case. I don't know. Look, 4 can't go around there, so 4's in one of those cells. 4 can't go around there, so it's in one of those. 4 can't touch this 3, so it's in one of those. That fixes that it can't be there, places it here. The knights move sees that cell, so we get a 4 there. The knights move sees that cell, so we get a 4 there. That sees all of these, so there's a 4 in one of those. I may have been getting overexcited. Why don't I finish 1s, 2s and 3s first? That's probably smart. Look, there's a 1 waiting to go in here. Oh, and here. And here. Right, 3 1s needed doing. The 2 is there. Oh, and that's all the 2s done. 3s. Let's just highlight the 3s we've got. Right, using the non-consecutive rule, 3 has to be... Ah, where's 3 in this column? Oh, that's very pretty. That 3 sees those 2 cells. That one sees those 2. That one sees that cell. This is a 3. Now, those can't be 3s, that's not so helpful. 3 is in one of those 2 cells. Non-consecutive says it can't be there. Sudoku says it can't be there. We seem to be ending up with an X-wing on 3s at the top and bottom. So 3 can't be there by non-consecutive. Oh, it's got to be here, so we get it done. Right. So I'm left with this X-wing on 3s. Now let's have another go at 4s. 4 has to be in one of those 2 cells using the non-consecutive rule and ordinary or non-consecutive Sudoku. 4 can't be there, there, or there, so it's in one of those 2. Can't be gathered around that, and it can't be there. We can place it here. That fixes it at the top. Knight's move sees that. Oh, it's lovely when this flows together. This is what miracle Sudoku feels like. 4, 4. One of those is a 4. But it must be diagonally touching the 3. One of those is a 4. I mean, don't shout at me if I miss some obvious reason. That 4's gone, so that's a 4. And that's going to fix all the 4s, just like that. And that fixes the remaining 3. Can't be there, so 3 in those positions. And we can take out the corner marks from those cells. Now, let's just hope this moves on to 5s. Why not? Those can't be 5s, so one of those is. Doesn't help in this box. One of those is. So therefore in column 8, it's one of those 2. One of those 2 has to be 5. That can't be. 3 possibilities. One of those 2. There's something. One of those 2. I'm just avoiding being next to 4 for 5. One of those 2. It looks like there's 2 or 3 cells. 2 cells in every box except this one where there's 3. What on earth does that mean? So, I don't know. I feel like choosing one and seeing what happens. So if that's a 5, it's a bit of a silly choice, but that means that the central cell's not a 5. So one of those is, so that's not. So that is, haven't broken any constraints yet. That one, and a sort of X-wing on 5s in the other cells. So that's possible. Whereas if that's a 5, you get this one. Is this the only position for 5 in column 3? I might have found that. Why have I... But I might have got it wrong. Why did I not think this could be a 5? It's not next to a 4. Those 2 are. Now I'm going to put a 5 in there as well. Sorry, so that invalidates my earlier thing. Oh, it doesn't actually. It's still... There has to be a 5 there in the column. Well, assuming I haven't made other mistakes, and believe me, I sometimes do. No, if that's a 5, then one of these 2's a 5, and that's a 5. Sorry, then one of these 2's a 5, and that's not a 5, so that's a 5. That's the right way around. That's what I did before. I understood it before. Why can't I understand it now? That one, and then this X-wing in rows 4 and 6. But if that's a 5, we get one there, we get one there. That does work. I thought it didn't. It does. We get one there, and there, and there, and there, and there, and there, and that works as well. So there are 2 ways of doing the 5s. Bother. Right, okay, what I was hoping not to have to consider is 8s, but 8s can't be next to 9s, so those aren't an 8. So there's an 8 in one of those 2 cells, and in one of those 2. This looks like a pattern that the 5's made on the other side of the grid. In one of those 2, they don't see anything. One of those 2. And then up here it's one of those three, annoyingly. One of those three. Do they all see? No. That can't be 8 and that can't be 8. So again, in every box, it's 2 or 3 positions. So if that's an 8, we get one there. There's one at the top. That must be one. I don't know what to do here. I'm not forgetting the knight's move. I'm thinking about that all the time. That would be an 8. I just don't think this resolves. And oh, that, hang on. Not that one, that one. That. Wow, okay, that's a set of 8s that works. And the alternative is here, which does what? There. 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 I mean, I suppose there's a chance that somewhere in doing this I've highlighted the same cell in both versions, but it really looks possible to do either 5s or 8s anyway. Now, think about the constraints. The negative radar constraint, how would that work? Well, 8s can't be relevant unless you had an 8 in a corner. That one is 8 away from that, but it's 5 away from that. This cell. Oh, I stumbled across that by thinking about 8s, but it's 5s. This can't be a 5 because it would be a radar cell. That's incredible. That nearest 9 is there. So on its radar, it would be showing 5. And if this was a 5, that would be grey. So it's not a 5. And I hope this suddenly resolves all my 5s. It puts a 5 there. Ah, maybe it doesn't resolve all the 5s. We can't have a 5 there, but we can still have these pairs everywhere. Oh, you're not serious. Do we have to go to bigger numbers? Oh no, I tell you what. The negative constraint on the non-consecutive's interesting now. Yes, it is. The other 3 digits we have to put in this box are 6, 7 and 8. But if you put 7 up here, it would either be next to 6 or 8. So it can't be there. So this is 7. Ah, so just getting 1 5, I think, enables that to operate. Weird, but there we go. Right, so this is a 6-8 pair. I don't know the order yet. Let's take the pencil mark out. 7 and 5, come on, let's see if this 7 now can't be in either of those cells. So one of these is a 7. I might go and do this dance around the grid again until I find something like that. That's so weird. Okay, this can't be 5 or 7. 7 has to be in one of those two. Ah, 7 is not useful anywhere apart from in this box. Come on, there can't be another negative thing. I mean, this can't be a 5, but it's not a candidate. It's hard to find these cells that are very remote. Oh, excuse me 1 second. I will just fix that. There we go. Right. 3, 1, 4, 2, 9, 5. Oh, what am I missing? Come on. Did 5 sort out the 5s? Now I'm thinking, oh no, I did have a 5 possibility here. I was wondering if this was always the only possibility in the row. 7 is in one of those cells. So this isn't a 7 or a 5. That's 6 or 8. That's 6 or 8. That can still be 5. Right, need to do more thinking. This is a very cunning puzzle. It really has stuff. Right, this can't be a 5-6 pair in the row because they would be next to each other. So 8 is in one of those 2 cells, but it can't be there. So it's there. That's how to think about it. Does that sort out 8s? Do you know? I don't think it does. Oh, we've got an 8 there and an 8 there. So I could have done this before. So we get 8 there. That's not an 8. Yeah, these two cells, when they're next to each other, they're interesting. Yes, that 8 looks down here. That can't be an 8. So we get 8 in this box. That means this can't be an 8, but that might run dry here. Oh, come on, you crazy puzzle. This is 6 or 7. That's not helpful. That can't be an 8 now. It didn't run dry. We get an 8 there. Those we knew couldn't be an 8 from before, but now that can't be an 8. Oh, it feeds around everywhere. That becomes an 8. Right, down here, this is a... Oh, that becomes 8. That's the useful. This becomes a 5, 6 pair in the column, and that becomes a 7. That's going to place a 7 here. Oh, we get 6 and 8. I think we might suddenly be on the home stretch here. Weirdly. 5, 6 pair there. I don't know. I may have called it too early yet again. It's such a strange puzzle. 5, 6 pair there. 5, 6 pair there. Come on, 7s or 8s or something. Yes, 8, 8. That's an 8. And that's not. What about 8 at the... Oh, there is an 8 at the top. So 8 here now. I think we might be done on 8s. 1, 2, 3, 4, 5. Yeah, that's all of them. But 8s now can't be next to 7s. So that's not a 7. So that's a 7. Yeah. Come on. So that's a 7. That's a 7. That's a 7. That's a 7. We are finishing now, surely. Everything else is a 5 or a 6. And somewhere, yeah, that 6 is going to help disambiguate them all. 5 there, 6, 5, 6, 5, 6. What a marvellous puzzle. 6, 5, 6, 5, 6, 6, 5, 6, 5. And that is the solution to the 18 radars. Thank you, Utopia. Sorry it's taken us a while to get around to it. That really is very clever and very 18 celebratory, which is what I was looking for. So thank you for that. Now do check out the Puzzle Hunt. If you like Miracle Sudokus and how they work, this is a great example. The non-consecutive constraint is just fascinating sometimes. But do check out the Patreon Sudoku Hunt or indeed our Miracle Sudoku app. Thank you very much for watching as always, and bye for now.